Section 3. The Hydrosphere and Biosphere. Life on Earth is restricted to a very narrow layer around the Earth's surface. In this layer, called the biosphere, everything that organisms need to survive can be found. One of the requirements of living things is liquid water. The hydrosphere and water cycle. The hydrosphere includes all of the water on or near the Earth's surface. The hydrosphere includes water in the oceans, lakes, rivers, wetlands, polar ice caps, soil, rock layers beneath Earth's surface, and clouds. The continuous movement of water into the air, onto land, and then back to water sources is known as the water cycle, which is shown in Figure 17. Evaporation is the process by which liquid water is heated by the sun and then rises into the atmosphere as water vapor. Water continually evaporates from Earth's oceans, lakes, streams, and soil, but the majority of the water evaporates from the oceans. In the process of condensation, water vapor forms water droplets on dust particles. These water droplets form clouds in which the droplets collide, stick together, and create larger, heavier droplets. These larger droplets fall from clouds as rain in the process called precipitation. Precipitation may also take the form of snow, sleet, or hail. Earth's oceans. We talk about the Atlantic Ocean, the Pacific Ocean, the Arctic Ocean, and the Indian Ocean. However, if you look at Figure 18, you see that these oceans are all joined. This single large interconnected body of water is called the world ocean. Its waters cover a little over 70% of the Earth's surface. As we will see, the world ocean plays many important roles in regulating our planet's environment. The largest ocean on Earth is the Pacific Ocean. It covers a surface area of approximately 165,640,000 square kilometers and has an average depth of 4,280 meters. The deepest point on the ocean floor is in the Pacific Ocean. The point is called the Challenger Deep and is located east of the Philippine Islands, at the bottom of the Mariana Trench. The Challenger Deep is 11,033 meters below sea level, which is deeper than Mount Everest is tall. Oceanographers often divide the Pacific Ocean into the North Pacific and South Pacific based on the direction of surface current flow in each half of the Pacific Ocean. Surface currents in the Pacific move in a clockwise direction north of the equator, whereas surface currents flow in a counterclockwise direction south of the equator. The second largest ocean on Earth is the Atlantic Ocean. It covers a surface area of 81,630,000 square kilometers, which is about half the area of the Pacific Ocean. Like the Pacific Ocean, the Atlantic Ocean can be divided into a north and south half based on the directions of surface current flow north and south of the equator. The Indian Ocean covers a surface area of 73,420,000 square kilometers and is the third largest ocean on Earth. It has an average depth of 3,890 meters. The smallest ocean is the Arctic Ocean, which covers 14,350,000 square kilometers. The Arctic Ocean is unique because much of its surface is covered by floating ice. This ice, which is called pack ice, forms when either waves or wind drive together frozen seawater, known as sea ice, into a large mass. Ocean water. The difference between ocean water and fresh water is that ocean water contains more salts. These salts have dissolved out of rocks on land and have been carried down rivers into the ocean over millions of years. Underwater volcanic eruptions also add salts to the ocean. Most of the salt in the ocean is sodium chloride, which is made up of the elements sodium and chlorine. Figure 19 shows the concentration of these and other elements in ocean water. The salinity of ocean water is the concentration of all the dissolved salts it contains. The average salinity of ocean water is 3.5% by weight. The salinity of ocean water is lower in places that get a lot of rain or in places where fresh water flows into the sea. Salinity is higher where water evaporates rapidly and leaves the salts behind. Temperature zones. Figure 20 shows the temperature zones of the ocean. The surface of the ocean is warmed by the sun. In contrast, the depths of the ocean, where sunlight never reaches, are very cold and have a temperature only slightly above freezing. Surface waters are stirred up by waves and currents, so the warm surface zone may be as much as 350 meters deep. Below the surface zone is the thermocline, which is a layer about 300 to 700 meters deep, where the temperature falls rapidly with depth. If you have ever gone swimming in a deep lake in the summer, you have probably encountered a shallow thermocline. Sun warms the surface of the lake to a comfortable temperature, but if you drop your feet, they fall into cold water that may be only slightly above freezing. The boundary between the warm and cold water is the thermocline. A global temperature regulator. One of the most important functions of the world ocean is to absorb and store energy from sunlight. This capacity of the ocean to absorb and store energy from sunlight regulates temperatures in Earth's atmosphere. The world ocean absorbs over half the solar radiation that reaches the planet's surface. The ocean both absorbs and releases heat more slowly than land does. As a consequence, the temperature of the atmosphere changes much more slowly than it would if there were no ocean on Earth. If the ocean did not regulate atmospheric and surface temperatures, the temperature would be too extreme for life on Earth to exist. Local temperatures in different areas of the planet are also regulated by the world ocean. Currents that circulate warm water cause the land areas they flow past to have a more moderate climate. For example, the British Isles are warmed by the waters of the Gulf Stream, which moves warm waters from lower latitudes toward higher latitudes, as in Figure 21. Ocean currents. Stream-like movements of water that occur at or near the surface of the ocean are called surface currents. Surface currents are wind-driven and result from global wind patterns. Figure 22 shows the major surface currents of the world ocean. Surface currents may be warm water currents or cold water currents. Currents of warm water and currents of cold water do not readily mix with one another. Therefore, a warm water current like the Gulf Stream can flow for hundreds of kilometers through cold water without mixing and losing its heat. Surface currents can influence the climates of land areas they flow past. As we have seen, the Gulf Stream moderates the climate in the British Isles. The Scilly Isles in England are as far north as Newfoundland in northeast Canada. However, palm trees grow on the Scilly Isles, where it never freezes, whereas Newfoundland has long winters of frost and snow. Deep currents are stream-like movements of water that flow very slowly along the ocean floor. Deep currents form when the cold, dense water from the poles sinks below warmer, less dense ocean water and flows toward the equator. The densest and coldest ocean water is located off the coast of Antarctica. This cold water sinks to the bottom of the ocean and flows very slowly northward to produce a deep current called the Antarctic bottom water. The Antarctic bottom water creeps along the ocean floor for thousands of kilometers and reaches a northernmost point of approximately 40 degrees north latitude. It takes several hundred years for water in this deep current to make this trip northward. Fresh water. Most of the water on Earth is salt water in the ocean. A little more than 3% of all the water on Earth is fresh water. Most of the fresh water is locked up in ice caps and glaciers that are so large they are hard to imagine. For instance, the ice sheets that cover Antarctica is as large as the United States and is up to 3 kilometers thick. The rest of Earth's fresh water is found in lakes, rivers, wetlands, the soil, rock layers below the surface, and in the atmosphere. River systems. A river system is a network of streams that drains an area of land. A river system contains all of the land drained by a river, including the main river and all its tributaries. As shown in Figure 23, tributaries are smaller streams or rivers that flow into larger ones. Some river systems are enormous. For example, most of the precipitation that falls between the Rocky Mountains in the west and the Appalachian Mountains in the east eventually drains into the Mississippi River. The Mississippi River system covers about 40% of the contiguous United States. Groundwater. Rain and melting snow sink into the ground and run off the land. Some of this water ends up in streams and rivers, but most of it trickles down through the ground and collects as groundwater. Groundwater fulfills the human need for fresh drinking water and supplies water for many agricultural and industrial uses. But groundwater accounts for less than 1% of all the water on Earth. Aquifers. A rock layer that stores and allows the flow of groundwater is called an aquifer. The surface of the land where water enters an aquifer is called a recharge zone. Figure 24 shows the location of aquifers in the contiguous United States. The biosphere. The Earth is often compared to an apple, and the biosphere is compared to the apple's skin. This comparison illustrates how small the layer of the Earth that can support life is in relation to the size of the planet. Scientists define the biosphere as the narrow layer around Earth's surface in which life can exist. The biosphere is made up of the uppermost part of the geosphere, most of the hydrosphere, and the lower part of the atmosphere. The biosphere extends about 11 kilometers into the ocean and about 9 kilometers into the atmosphere, where insects, the spores of bacteria, and pollen grains have been discovered. Life exists on Earth because of several important factors. Life requires liquid water, temperatures between 10 degrees Celsius and 40 degrees Celsius, and a source of energy. The materials that organisms require must continually be cycled. Gravity allows a planet to maintain an atmosphere and to cycle materials. Suitable combinations of the things that organisms need to survive are found only in the biosphere. The biosphere is located near Earth's surface because most of the sunlight is available near the surface. Plants on land and in the oceans are shown in Figure 25. Plants need sunlight to produce their food, and almost every other organism gets its food from plants and algae. Most of these algae float at the surface of the ocean. These tiny, free-floating marine algae are known as phytoplankton. Except for bacteria that live at hydrothermal vents, most of the organisms that live deep in the ocean feed on dead plants and animals that drift down from the surface. Energy flow in the biosphere. While energy is constantly added to the biosphere from the sun, matter is not. The energy used by organisms must be obtained in the biosphere and must be constantly supplied for life to continue. When an organism dies, its body is broken down and the nutrients in it become available for use by other organisms. This flow of energy allows life on Earth to continue to exist. In a closed system, energy enters the environment, but matter does not. Today, the Earth is mostly a closed system with respect to matter, but is still an open system for energy. Energy enters the biosphere in the form of sunlight, which plants use to make their food. When an animal eats a plant, the energy stored in the plant is transferred to the animal. Animals in turn eat other animals. At each stage in the food chain, some of the energy is lost to the environment as heat, which is eventually lost to space. In an open system, both matter and energy are exchanged between a system and the surrounding environment. Matter was added to the early Earth through the collisions of comets and meteorites with our planet. Now, however, little matter reaches our planet in this way.